this problem, we have a car, and for NASCAR, or race car, and it's being tracked by this camera. And as the car is traveling towards the finish line, the angle of the camera is gonna swing to follow the car. So if we're told that the speed of the car is 180 miles per hour, we wanna find out how fast is this angle changing so the camera stays fixed on the car. So the first thing we need to do is we need to draw two triangles. We need to draw a position triangle and a rate triangle. My first triangle is going to be position, that's going to be rates, and let's label some of these sides. We'll call this guy C, call this guy A, and this guy B. So in this triangle, which is going to be we'll call him my rate triangle and him my position triangle, I know that, just filling in the given information from the problem, the speed or rate of the car is 180. And because the car is sitting on this leg, on the A, this guy is going to be, we'll call him dA dt for now. And this guy is B, and we'll call him dB dt. And this guy, which is C, we'll call dC dt. Now for the position triangle, let's fill out some of the sides. So we know that this 132 is going to stay 132. And we want to know d theta dt when the car is right below the camera. So if the car is right below the camera, the length of this line A is going to be 0. So I know it doesn't look like it in the picture because I drew it with some dimensions, but we're going to say that's 0. And from that, we can also figure out the length of this line. Because this is 0, this has to be 132 as well. Because when this is 0, these two are right on top of each other. So now what we're going to do is we have to find a function for theta that relates what we know and what we want to know. So we want to know this guy, the rate of theta. And what we know is we know a lot of stuff happening down here. So I need something to relate an angle and an opposite leg. So what do I know? Well, I look at SOHCAHTOA, and I say, well, to relate an opposite leg, I need the sine, an angle, and a hypotenuse. So I'm going to say that sine of some angle theta is equal to the opposite divided by the hypotenuse. The opposite is A, and the hypotenuse is C. Next step we're going to have to do, this is our position function, and it's a function of some angle theta. So in order to find a rate function, we need to take a derivative of our position function with respect to time. So we want p dot of theta, or d dt of p theta, dp dt, and that's equal to the derivative of both sides, left and right. So what we're going to do is the derivative of the left side, sine theta, is going to be equal to cosine theta. Theta is a function of time, so we have to use implicit differentiation and slap on a d theta dt. And we know that's equal to this side. It's a quotient of two things, two functions that depend on time, so we need the quotient rule. We know the quotient rule is low times derivative of the high minus the high times the derivative of the low, all over low squared. So we're just going to pop in these numbers. The low, that's C. The derivative of the high is going to be dA dt minus the high, which we know is A, divided by, or sorry, not divided by, minus the high times the derivative of the low. Derivative of the low is going to be dC dt all over the low, which is C squared. Now we're going to go pop in things. We want to find d theta dt. So to solve for this, we're just going to divide both sides by cosine theta. So what we're going to get is we're going to say d theta dt is equal to C dA dt minus a dc dt divided by c squared cosine of theta. Okay, now we have to fill in information that makes this equation relevant to our situation. We wanted to find out the rate of the angle with respect to time when the car was right below the camera. The angle that's going to be, the camera is going to have pointing down here is going to be 0. So we're going to have to plug in 0 for cosine. Cosine of 0 is 1. So this term is going to cancel out. We also know that this length A, you can see we labeled our triangle A, he's 0. Right when the car is here, this length from the car to the finish point is right on top of each other, so the length is 0. This is 0, that goes away. So all we have left to fill out is c, dA dt, and c squared. So we're going to know that this c is going to cancel with one of the exponents there. And all we're going to be left with is d theta dt is equal to dA dt divided by c. And we know c is this length right here, 132. We talked about that earlier. 132, and that's in units of feet. And now we have to find dA dt. Go to our rate triangle, go to side A, and say, what is dA dt? It's the rate at which this side is changing. This side is represented by how fast the car is moving, because that will tell you how long the line is. How fast the car is moving tells you how fast that line is getting short, and that's given by the speed of the car, 180 miles per hour. What we have to do is we're working with feet, so we have to make a unit conversion from miles per hour into some unit with feet in it. So we're going to have 180 miles per hour, and to convert from hours to seconds, we have to say, all right, let's how many hours in, how many seconds are in 1 hour? And that's 3,600. So we have to do 180 divided by 3,600, and we see that hours are going to cancel, and all we're going to be left with is miles per second. So, does anyone know what 180 divided by 3,600 is?
1 over 20.
1 over 20, so we get 1 over 20 miles per second. And then to convert this guy, we have to say, all right, we need him in terms of feet, so we say miles down here, feet in the top. We need to know the units have to cancel, so if we have miles in the numerator, we want to cancel them by putting miles in the denominator. So we say in 1 mile, how many feet do we have? And it's 5,280. So we know miles will cancel with miles, and what we're left with is feet per second. 5,280 divided by 20,
264.
264. So equal 264 feet per second. So I'm going to come over here for this dA dt. We found it's going to be 264 feet per second. And when you divide these two quantities, the feet are going to cancel. And what do you get?
2.
2 is equal to 2. And that's 1 over seconds. So the answer is d theta dt, right in the center. D theta dt, or theta dot, is equal to 2. 1 divided by second.